and then probably be able to end this part. Then the next class will be hands-on. All right. Kruska-wallis is a non-parametric test, and then it is used to compare medians together, that is between three or more independent groups. Okay, so the alternate of Kruska-wallis we used to say is your this ANOVA of a thing, where you are comparing between two or more groups, three or more groups. Okay, so in the parametrics we use your ANOVA, but for non-parametric data set we use Kruska-wallis. Now, how does it work? For you to use Kruska-wallis test, your dependent variable must be either ordinal or continuous variable, and your independent variable must be a categorical variable that is that is between three or more groups, just like we have it in ANOVA. If you remember, we did make mention of ANOVA in our last class. So your independent variable must be categorical with three or more groups. Okay.
Yes.
Another conditions that your data need to satisfy before you can use Kruska-wallis is that your data do not have assume normality. What do we mean by that? Your data do not follow normal distribution. It is not normally distributed. Okay, so then it has independent observations. So when you want to use Kruska-wallis test, you must check to ensure that your data fits in to these conditions. Having satisfied these conditions, you can then proceed. So it is used to compare, to test for effect, or compare two or three medians and above rather. So, and that is the opposite of your ANOVA. When you have parametric test and you want of you running ANOVA, non-parametric rather, you use Kruska-wallis. Okay, let's proceed. We then move on to mann-u-whiteny test. Mann-u-whiteny test. Okay, mann-u-whiteny test is the opposite of your t-test. Okay, in non-parametrics. Now, it is used to compare the median of two independent groups. If you remember very well, when we consider t-test, we said we have one sample t-test, we have independent sample t-test, we have paired sample t-test. Okay, so now the conditions for your t-test, we said the dependent variable must be continuous and the independent variable must be categorical. Now, the same thing here for you to run mann-u-whiteny test, the dependent variable must be ordinal or continuous. So either ordinal or continuous, it still fits into your dependent variable. Then for independent variable, it must be categorical, that is two groups, binary, two groups in nominal variable, okay? Two groups. So then the independent variable, that is independent observation. Not only that, the data do not follow normal distribution. Okay, so when your data do not follow normal distribution and then you want to compare the medians, you are using medians. You know, medians, mean, mode, these are all central tendency. Okay, we use them to get our central tendency for our data set, data. Okay, so if what you are using is median, okay, for non-parametric test, and you needed to check if there is significant difference you are comparing between the independent variable and dependent variable, okay, you can use mann-u-whiteny test. Is that okay, please?
Yes.
Okay, let's proceed. We have linear regression. Okay, usually all of our regressions, they are being used to prediction. Okay, so, and to predict a continuous dependent variable based on one independent variable. All right. Linear regression basically deals with one dependent variable and one independent variable. Now, when do you use linear regression? Uh, Let me say the before I look at the condition. When you are testing for effects, okay, you want to know if there's causative effect, cause and effect. Okay, does this variable cause this thing? Okay, for instance, the house is leaking. What can be responsible for this roof leaking? Okay, that is the problem is existing. So we want to know what may be responsible. Okay, so cause and effect, we can use that is the essence of regression. Now, when your data is just one dependent variable and one independent variable, okay, now other assumptions that you need to also check is this. One, the dependent variable must be continuous, and the independent variable can either be continuous or categorical. Okay, that is for independent variable. Now it can either be continuous or categorical, so it's not necessarily that it must be categorical. Now your variable, that is the relationship between this variable, must be linear. That's why we call it linear relationship, linear regression. Now how do you check? These are the, I know I've once said this, the assumption you need to fulfill. So how do you know that there is a linear relationship between this variable? That is why usually we used to run PP plots. Okay, PP plot, that is for linear. We have QQ plot, that is for multiple linear regression. Now when you run your PP plot, it plots the two variables on a linear graph. Okay, now if the dot all these variable, they are close, they are compacted towards the linear graph, your straight line. Okay, we said okay, there's a linear relationship there, we don't have outliers. But if they are not compacted towards the linear graph, your straight line, maybe they are just scattered abroad, we said, this thing do not really follow linear graph, they do not obey this condition. So with that, we cannot run linear regression. So basically, when people state in their method of analysis that they are using linear regression, one of the assumption tests, that though it's not, I said it's not common in Nigeria anyway, in developed countries, they will ask you to submit your linear chart. Let them see if the variables, your data, actually satisfy this condition before proceeding to your linear regression. Okay. Then another thing is we check for the homoscedasticity and normality, that is how your data are being distributed. Are they normally distributed or they are not? Now to check for normality, you use histogram as a chart, okay, because it will now plot that curve, that diameter curve round, not circumference, at the half of circumference. To plot it for you round, then we will now look at it. All the chart, are they compacted inside it? Now, if you don't want to use histogram, you can as well use Kolmogorov-Smirnov or Shapiro-Wilk. Kolmogorov-Smirnov and Shapiro-Wilk are being used to test for normality of your data. So, it is expected that before you run your linear regression, your data must satisfy linear relationship, and that is why when you run it, one of the results you get as well is a relationship table. Okay, you see a relationship table telling you if there's a relationship. You see ANOVA table, you see coefficient table, you see this homoscedasticity table as well. Okay, so it is expected that your data is linear, not we have maybe polynomial, not exponential, not that kind. No, it must be linear. That is why we used to use a scatter plot. If you are using the exam, use scatter plot, you see it, you show the dreaded line. So it is important that it satisfies these conditions and then it is normally distributed. And please do not forget, it is between one dependent variable and one independent variable. Please, do you have question before we proceed?
Yes. At
Okay.
this time, when you have, so doesn't have anything to do with moderation. If you have anything, if you have something you want to either mediate or moderate. How do you handle it at this point?
Okay. Now, if you have, let's assume you have independent variable, you have mediating variable and dependent variable, right?
Yes.
Okay. Now, at this point, you may not be able to use linear regression for it, okay? Because you have three different variables. Like the one we did that has all these three things. All we used was PLS, that is PLS. Okay, that one, that regression enabled us to factor in the independent variable, the mediating variable, and the dependent variable. Actually, we are testing a model. Okay, so that was what we used to be able to achieve that. But once you can't use linear regression for such purposes.
Okay, thank you.
All right. So let's proceed. Then the multiple linear regression now. Now for multiple linear regression, it's the same thing as your linear. However, the difference is we have more than one dependent variable. Okay, independent variable rather. We have more than one independent variables, and we have just one dependent variable. Okay, so you can have two, three, four, five independent variable. All of them, you are looking at the relative effect. When you are checking for relative effect, in the sense that you are looking at the individual effect of these variables on the dependent variable. Okay, that's the relative effect. Now, if you are looking at the composite effect, the composite effect is all the effect put together of those variables on the dependent variable. Okay, usually whenever maybe we have such hypothesis in research work and say, okay, there's no relative effect between they mentioned the independent variable, maybe leadership style and institutional policy on job performance. Now, that is, and that's me, and that hypothesis may state that there's no composite effect between leadership style and the institutional policy on job performance. Now, once you run your tests, it will bring out the relationship table, to bring out your ANOVA table, to bring out the coefficient table, and other tables. Now, what we used to use for relative effects is the coefficient table. Then we now rank the standardized beta value. Now, why do we do that? The beta value stands for your relationship, okay? The coefficient table shows us the coefficient effect or relationship between between each independent variables on the dependent variable. You can see it. Okay, this is the beta value, that is the relationship value. This is the t-test value. It will give you your t-test value, and as well, it will give you your p-value. That is the significant effect value. Okay, now you can, okay, this one have more effect. There's even one work we did one time that the person stated that, okay, burnout has something, is it burnout, something have more effect than the other. That is one statement like, so you, that's okay, no, this one actually have more effect than this. Then somebody can say, okay, it has a negative effect. Do you get it? Then you can, or negative relationship. Somebody look at it from that beta. Once it's negative, say yes, so this is negative. Okay, so the coefficient table gives us the individual effect of the independent variables on the dependent variables. Please, do you understand?
At the point I lost you. When you want to say that there's a time you did your say work.
Yes. Okay, let me recap then.
So from there I lost you.
Okay. I said there was a work that we use this relative effect, composite effect. So, and I said that relative effect actually helps us to identify the individual effects of the independent variables on the dependent variables. So we tested that, okay, let's check the effect of this burnout on is it patronage? It was on the research was on telecommunication. Then we looked at the other one, the other variables, and there were three variables, and we're able to see the difference. One have more effect than the other, followed by, so we now rank it. You will usually rank the standardized beta value, because your coefficient table will give you unstandardized beta value and standardized beta value. That is, and that beta value is what we call the relationship. It tells us the relationship. Okay, so now you can fetch out the effect of respective independent variable. And I've said that the composite effect, we usually use ANOVA, because that one will not give you it just tell you that all these independent variables, oh, they have significant effect on your dependent variable, and if they do not, it will tell you that they do not. Oh, so that is composite, that is holistically the three of them or the four of them, they do or not. But if you want to look at the relative effect, that is the individual effect, we use the coefficient table. So once you run your test, especially on SPSS, and you at least, I know that it will give you all these tables, then you can now pick the one you want to use for your work. Please, do you understand?
Yes, I do.
Okay. So now the conditions again that you need to do for this, for you to run multiple linear regression, your data, it must be a linear relationship. So how do you do that? I said we used to use QQ plots. Okay, for multiple linear regression we use QQ, while for linear regression we use PP. Okay, then it must also follow normal distribution, so you can also use your histogram. Then we must avoid multicollinearity among predictors. So usually we check for multicollinearity. There's a way you do it on your software that will give you your VIF value, tolerance value, like that. And you can check and say, okay, no, there's no multicollinearity, because if multicollinearity exists, maybe there's a gap, like you are saying, no, this data set, check it, or it doesn't fit in. So when we get to the practical aspect, I will show you okay, this is how to get multicollinearity. Okay, and then to test for your normality, you test for it, and then the linear relationship respectively. So once you have achieved those conditions, okay, you can proceed with multiple linear regression. You must just understand that you must have more than one independent variable to run multiple linear regression. Please, is that okay?
Yes.
Okay.
But then I have a challenge,
Okay.
and that is when you have a construct,
Yes.
and for example, you have work-life balance.
Yes.
You want to see how work-life balance,
Yes.
maybe the relationship between work-life balance and workload or technology,
Yes.
or I'm trying to look at a very work-life balance and maybe organizational performance.
Okay.
Now, now to now look at the constructs.
Yes.
That may be out of this class, so but sometimes I have this challenge. So
Okay.
it's like, okay, which construct will we use to measure this main variable?
Okay.
Because sometimes if you don't get the right constructs to
Yes.
measure it,
Yes.
even if you just go and get something, we will still run it,
Mm.
but we will not get the true picture of the survey or the problem. Now,
Okay.
how do we get measures
Okay.
for the main variables so that it will be like, okay, this is the main issue, like a problem if we are looking at change implementation
Yes.
as a problem.
Yes.
Now, how do we get things to use
Okay.
to measure change implementation so that well, we will not Okay.
Um, One thing I've come to realize is we have the research is built on previous work, one, and then since it's social science or management and humanities, as the case may be, I'm sure you know that we have existing theories that governs like management of change if you are dealing with change, or if it deals with life and balance. There are some theories existing already that are relevant to the topic, right?
Yes.
Okay. So now, if you are using any of those theories, it will save you a lot of stress because they are relevant. Is a because I remember one of these people asked, "If you are using this, how is it related to the work?" So if you are using any of those theories to measure that work, you save yourself number one stress. The second thing is you can now look at uh how, because those theories they also use metrics. They analyzed it before they are able to say, okay, this theory has been tested and proven before it became a general acceptable theory in the society. Okay, now there were some measures that they use, some constructs, okay, that they use, which can help you. That is one. So you can pick from there and look at their measures and then adapt it to your own work. That is, you edit it to fit into the context of what you are dealing with. So that will help a little bit than just scouting. Okay, how do I put these variables? Okay, how do I write these things? So if you can look at theories, existing theories that is measuring those variable, it will save. Now let's now assume that you don't want to use theory, because I feel like that theory is the basis. Nobody once theory is adopted, you are using theory, nobody will question it too far. As long as it is related, everybody will keep short. But if the theory is not related, that is where the problem. Oh no, it's not related. This other theory is more related. So, but if it is related, and you say, okay, I use also theory to measure this variable. So the instrument used was adapted for this work. So once you adapt it, it will save you. So that is for answer number one. Answer number two, if you don't want to use this thing, let's as the theory, you can also check related works. Probably you now have your objectives, objective one to now you can check related works and see those ones. Maybe one article may deal with one of your objectives, and that different article may deal with the other objectives, and look at how they were able to measure their variable. Because now, if you are at this point, you want to adapt it to your own situation, then you can now edit it to fit in to your own work. So somebody else can adapt your own metrics too for their own work. So it will save a lot of stress than you building from scratch. Okay, which question am I going to ask? How you understand? Because you will just be racking your head. Okay, I want to ask this question. I want to ask, is it even related? Now, when you now go for data validation, you now validate it. So the respondent may not even understand this thing, or you understand. I remember it happened to me, my MSc work. I even though I adapted an existing metrics, it was I worked on information system. So the work was from the other person I adapted his work, did his own in Egypt, and it was pure information system while mine was on Turnitin. So I adapted, the my supervisor said it's okay. By the time I got to the field and I met those in education, and I said, "Ah, no, this thing you are okay." Then there was even one of my respondents. They made input. It was on while right on the feed. I started adjusting it again to fit into what they can understand, because some of them were asking, "What do you mean by this? What do you mean by?" I had to now begin to explain this is what I mean. Saying you would have put it in this way now. So that is why if you are even adapting, you have to now subject it to a little bit validation, let other people make their input. So it will save you a lot of stress. Then you can then proceed for the actual work. So you can use, if you don't use theory, you can use related works and look at how they measure their constructs relevant related to what you are measuring. Okay. Now, if what you are doing, maybe somebody have not written, how to bail yourself out is to you look for a theory that can help you.
Okay,
Please.
thank you.
Yes. So do you understand?
Yes, I do.
Okay. All right. So let's proceed. Panel regression. Okay. Is another type of regression, and it is used to analyze data that involves multiple entities over time. Multiple entities over time. Like usually, this panel regression they used to use it very well in econometrics. Like you want to predict when are we going to start making profits, and you have so many factors to consider. Okay, so data must have both cross-sectional and time series dimensions. Okay, so that is the one of the condition. Your data must have a both cross-sectional and time series dimension. It must have a column for time. At if you are using month, January, February, March. If you are using year, 2010, 2011, that's a period of 10 years. Okay, and then you now have different other variables. So the independent variables can either be continuous or categorical. Then model assumptions, your assumption now, it depend on fixed effect or random effects. Okay, you can define, okay, this as let's assume that at a constant time we are having a inflation rate of 0.2. That is fixed effect. But if you don't have a fixed effect, maybe we don't have a constant value, it's a random. So the system automatically just do it randomly. Just okay, if we just calculate the geometric progression, if the difference between first year and second year is just 2, so the other one can move to times 4 and can start to use approximate progression. Okay, so that is random effect. So it depends on what you want to achieve when using panel regression. But this is common to econometrics, those that is who are into economy. I want to determine the date we are going to we will be free from inflation. All right. The next one is multivariant analysis of variance. Multivariant analysis of variance, that is maneuver. The purpose of this is to compare means of two or more groups for multiple dependent variables. Okay, so this time around you have not just one dependent variable. Now you have different multiple dependent variables. So and you want to now check if there's significant difference between them. Okay, you can use a maneuver. So the under conditions is okay. Your hand is up. Let's hear you out.
When you say we want to use it to compare two multiple variables,
Yes.
that is maneuver.
There's two
Now,
dependent
when
variables.
multiple dependent variables
Yes.
on the independent variable.
Hmm.
Abi?
Yes.
Okay. So we have one independent variable, but we
Yes.
want to compare multiple independent variable to the
Yes.
independent variable to
Yes.
see how that is a maneuver.
Yes.
Okay.
Hmm.
Thank you.
All right. So the dependent variable can be it must be two or more continuous variable. That is your dependent variable. There must be more than one. So two and above continuous variable. So it must be continuous variable. Then the independent variable must be categorical. Okay, it must be categorical. Then we have multivariant norm. You check for the normality. Okay, does it follow normal distribution? The homogeneity of the covariance matrix. Also check for the homogeneity, yeah, the closeness between them of the covariance. So, but what is significant here is that you have more than one dependent variables. Okay, so once you have more than one dependent variables, then you can think of using a maneuver, okay, to check, okay, these dependent variables, do they really have effect on the, is there a relationship, big differences between them and the your independent variable, okay. So basically that is where we use maneuver, okay. So in summary, we have this. I'm going to send the notes. We have all this. It can
Yes, yes,
it
yes.
can be a guide.
I need your I need all this notes o.
Okay,
Ẹ
okay.
Mm.
So we have all these tests that I've been considering. The what?
Already. Better even whatever it is, me and you. When I want to do all these tests, I will still come back to my teacher o. I'm a lifelong learner o. I cannot I will graduate, but I
You
will
got
still need handwork a very long time o.
so dependent variable, the independent variable, and the conditions they need to fulfill. Okay, so we have
Okay.
all this. So we're going to stop here today. In our next class, we are going to start with the practical aspect. I don't know yet how far you have gone with the Google form. Okay, so we're stopping here tonight. If you've not subscribed, please do well to subscribe. And in the comment box, I want you to mention any of the tests that you've learned and state the conditions that you need to fulfill, that the data need to fulfill before proceeding with the test. So have a wonderful night rest.